Oh, because if we got the limit of 5 over x squared, remember the limit of a constant over x to the any power is just going to be 0 as it approaches infinity. And we did the same thing here.
And so because the limit for 2x is infinity,
Yeah.
that's why we got the infinity.
Yeah. So actually that probably would make it a little clearer if I put infinity plus 0. There we go.
I'm probably just missing something here, but how would we be able to divide by the highest variable? Like,
oh, because if you get...
would it just be 1 over 1? Or like x over x?
Yep, but if you... Well, actually, if you... Let's say we rewrite this real quick. So if you have 2x to the third plus 5 over 3x squared plus 1, if you multiply them both by 1 over x squared...
Oh, okay.
Yeah, then just distribute them both.
And then at that point it's still a constant technically, but yeah.
Yeah.
Okay.
Kind of separate that a little bit. All right. Any other questions on this one? All right. Oh, you want still writing? Okay. Okay, so let's say, for example, I want to find the limit of, let's say the limit as x approaches infinity of 3x minus 2 over the square root of 2x squared plus 1. Move that up a little bit. Now, whenever you have those square roots in the denominator, it can get a little bit tricky. But there's one shortcut to simplify, because if you plug in infinity in really big numbers, you just get infinity over infinity again. Okay, so for this one, you want to remember that x is equal to square root of x squared. And that's only because you're approaching infinity. If you're approaching negative infinity, then you would have x equals negative square root of x squared, because it would be a negative x value. Okay.
X equals.
Yep, square root of x squared. All right, so let's say if we divide both by x. Oh, it's one of those exponent rules that's really easy to forget. Kind of think of it this way. It's, you know that square root of x is just x to the 1/2 power. So if we have the square root of x squared, that's just x squared to the 1/2 power, which is just x squared times 1/2, which is just x to the first power.
If we were to divide by x over 2, would that screw the problem up?
If you divide it by x over 2?
Yeah, we didn't realize that's just x.
Which part are you looking at?
What we're about to do.
Oh, x. Oh, you mean if you just divide by x squared?
Yeah.
Oh, x squared. Oh, that would throw it off, because here you'd have 0 over 0.
Okay.
So it might not be right. Okay, so here, if you think of that, then if you divide both by x, then that means the limit, so you have 3x minus 2 over x over square root of 2x squared plus 1. We're going to divide it by x, but we're going to divide it by the square root of x squared. Clean that up just a bit. There we go. So if we want to go ahead and clean that up a little bit, actually I'll put it underneath it. Something tells me I'm going to run out of room if I keep going to the right. That gives us, separate that, 3x over x minus 2 over x divided by, make that a little bit bigger, square root, because you have the square root and the square root, you can actually just combine the two. 2x squared plus 1 over x squared. Okay, so that's going to give us the limit as x approaches infinity. The x's here would cancel out, so it gives us 3 minus 2 over x. Over here, that will become the square root of 2x squared over x squared plus 1 over x squared. Okay. From there, you have the limit as x approaches infinity. Just kind of keep simplifying our denominator before we keep going. Those two x squares cancel out. So you have the square root of 2 plus 1 over x squared.
It's just 0.
Yep, so that will become, actually these will both become 0. So as you plug in bigger and bigger and bigger numbers, these two approaches 0, and this one approaches 0.
So should it be, so the answer would just be 3 over the square root of 2?
Yep, so it would be 3 over square root of 2. So you have 3 minus 0 over square root of 2 plus 0, which is 3 over square root of 2.
Would you have to simplify that to be 2, or square root of 2 multiplied by 3 over 2?
I don't think you have to rationalize the denominator. If you do, they should tell you in the problem.
And this only applies to if x is going to, or if it only applies when you're substituting x for infinity or negative infinity?
Yep, that's when it equals 0.
0,
Yep.
okay.
All right. Any other questions on this one?
So if we were approaching negative infinity, we would use negative square root x squared?
Yep, you use negative because if you're approaching negative infinity, then you're just getting really, really big negative numbers. So now if, actually let me write a little note for that. So if this problem had the limit as x approaches negative infinity, then we know that x would be a negative number. So that means that x would equal negative the square root of x squared.
So ultimately, that would end up being negative 3 over 2?
Yep, that's it. Yep, so it then would have been negative.
Yeah, negative 3 over square root.
Yep, so that means the limit as x approaches negative infinity. Let me go ahead and 3x minus 2 over the square root 2x squared plus 1 would be negative 3 over square root of 2.
So you just attach negative onto it, and if it becomes a double negative, then you would just make that into a positive if necessary. Like you
Yeah.
don't necessarily have to worry about the accident value because it would just be either, it would still be a plus, or 3 plus 0, and then square root of 2 minus 0. I think I'm just mixing but that's how I thought it would be if you substitute. Well, there is no such thing as negative zero.
There's no such thing as double
Hmm.
negative on this. On
Well,
this, there
yeah.
would be no
If
such
you
thing
look
as
at it,
double
it's x equals negative square root of x squared. If you would, when you're probably looking at that negative x up top, or you're thinking about something else.
Well, I thought that when you, because we said that, like negative infinity would equal zero, but
Mhm.
just in its negative format, so I thought that
So the
negative zero.
The reason this one would be negative and instead of not negative is because the negative's on the outside of the square root.
Right.
side.
Mhm.
So therefore, that doesn't apply to the inside.
Yep, so everything here, if you did all of this, you'd still have that negative
On the outside.
square root of x squared. So that negative would just move from there to there to there to there, and eventually.
Versus the previous example.
Yep.
It was all contained inside there, so that, it ended up being negative zero, and negative zero is,
Yep.
or negative, whatever it may be. So,
Yeah, that makes a bunch of sense.
All right. Any other questions on this one? Okay. Try to cover as many possible examples you may run across. Okay. So what if we have a polynomial?
bring it down.
Oh, sorry about that. At infinity. Okay. So if you have a polynomial at infinity, you kind of just want to ignore everything except the lead coefficient and the lead exponent, variable. Okay. And I'll explain why in a second. So limits of a polynomial. As x approaches either positive or negative infinity, just look at the leading coefficient and degree. All right, so let's say, for example, if you want to find the limit, let's say you have the limit of negative 2x squared plus 5x minus 10 as x approaches infinity. Okay, so you want to ignore everything except your lead coefficient. So the limit of negative 2x squared plus, and the rest of that doesn't matter at all. And the reason why is because once x gets big enough, if you have 20,000, or let's say 2 million, negative 2 times 2 million squared is pretty much going to dictate how that graph goes. If you have 5 times 2 million, it's not going to really change it a whole lot. So this lead coefficient or lead term is the one that's going to pretty much call all the shots. So that's why you just really worry about that, and that'll tell you everything you need to know. Okay. So here we already know that x squared is just a really large positive number. When x approaches infinity. Okay. So as x gets bigger and bigger and bigger, x squared just keeps getting bigger and bigger and bigger, and you know it's positive. Okay. So now we have that really big positive number from x squared, and we're going to multiply it by negative 2. Okay, so that large number, let me write out the actual large in case people don't understand my shortcuts. That large number multiplied by negative 2 now becomes negative. Well, you can say, and I hate to do this because it's technically not right, so it becomes a large negative number. And I put large in parentheses because as a negative number gets bigger, like negative million, negative billion, negative trillion, it's actually getting smaller, so I didn't want to say a large, that's why it's large in parentheses.
Becomes a large looking number.
Exactly, a very
Just as negative.
large looking negative number, so it's large. Yeah, I don't want anybody saying, he said it's a large number. No, it's technically smaller, getting smaller, but large in size. Okay, or in absolute value, rather. Okay, so now we know that it's just getting larger and larger and larger negative number. This is going to lead us closer and closer and closer to negative infinity. Okay, so the limit, and so this leads us to negative infinity. Okay, so we know the limit of negative 2x squared plus 5x minus 10 as x approaches infinity equals negative infinity. Okay, and we're going to use that same approach for all the other polynomials. All right, so let's say anyone's still writing? Nope, I'll leave it up for a few seconds. Nope. I was like one or two more quick examples like this one. Oh, for that one we were done. Yeah.
So we're something more.
Oh no. I know for polynomials they're pretty straightforward and not a whole lot of manipulating going on. It's the fractions and root symbols you have to really work around. All right, so let's say, for example, if we wanted to find the limit, okay, so let's say if we have the limit of 6x to the third minus 3x squared plus 3x minus 1 as x approaches negative infinity. Okay, so we're going to look at first, we know that negative infinity, now, I'm not going to use the parentheses there because I'm going to use the parentheses, is a really, and again, large negative number. Okay, so that's why I put the large there again. So it's a really big negative number. Now, when you get that really big negative number, we're going to get that, well, actually, I forgot to do the, so let me move this up a little bit because I forgot one part of it that I usually start with, and that's the limit of 6x to the third, and everything else kind of doesn't matter. So we're really just focusing on that. That's what I forgot to put. Okay. So we know we're going to get that negative number, that really big negative number, and raise it to the third power. So our really big negative number raised to the third power will still just give us a really big negative number, because negative times negative times negative is still going to be negative. Okay, so that really large negative number to the third power stays negative as x approaches negative infinity. Okay, so with this x cubed, that really big negative number here stays a really big negative, or it gets even bigger, but it stays negative. Okay, so we still have a negative number. Now, if you multiply that negative number times a positive 6, once again, it stays negative. Okay, so that really large negative number times positive 6, again, it stays negative as x approaches negative infinity. So now you just have a really, 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 really big negative number. Okay, so that means the limit as x approaches negative infinity, 6x to the third minus 3x squared plus 3x minus 1 is equal to negative infinity. All right, now it won't always equal negative infinity. Sometimes it equals positive infinity. But when dealing with polynomials, you're looking at either negative infinity or positive infinity. Yes.
So, one or two things.
Mhm.
Is that same question,
Mhm.
if it was x to the fourth, it would equal positive infinity, and if it was like, say, times negative 6, it would equal positive infinity, am I correct?
Oh yeah, if you had 6x to the third, but that was negative 6,
Yeah.
because when you get done with this step, this step, you still have a negative number to the third power. But if you multiply that negative number times a negative 6, it would have become positive.
Right.
Yep.
And then, or if it was raised to the fourth.
Yep, if it was raised to the fourth, then whatever large negative number to the fourth power would have been positive. Yep, exactly.
Okay. Just wanted to clarify that.
Oh, I get it. All right, any other questions? All right, one more quick example. Okay, so let's say if we want to find limit. Okay, so let's say for problem A, we have the limit of sine x over x as x approaches infinity, which should look familiar. We already know that's 0, but now we're going to see why it's 0. And for B, the limit of 4 times tangent of 1 over 4x plus 1 as x approaches negative infinity. Oh, and actually I'll do one more, just in case you run across it. The limit of sine of x as x approaches infinity. Now, the limit of sine of x and cosine of x as they approach infinity are probably the easiest, because it's always going to be they don't exist, because it's going to isolate between negative 1 and 1. So whenever you have just plain sine x or plain cosine of x, and it just bounces between 1 and negative 1 all the way to infinity, it just doesn't exist. All right, but for A, you want to remember that negative 1, well, sine x is between negative 1 and 1. Okay, so if we divide each term by x, you have negative 1 over x less than equal to sine of x over x less than equal to 1 over x. Okay. Now, if we apply the limit as x approaches infinity to each one of those, you have the limit of negative 1 over x as x approaches infinity less than equal to the limit sine of x over x as x approaches infinity less than or equal to the limit of 1 over x as x approaches infinity. Okay. Now we know the limit of a constant over x to the any power as it approaches infinity is 0. So here we have 0 is less than or equal to the limit of sine of x over x as x approaches infinity. It's less than or equal to 0. Okay. So just remembering the sandwich theorem, or squeeze theorem, whichever, I forgot which name this book used. I think it's squeeze theorem. By the squeeze theorem, the limit sine of x over x as x approaches infinity equals 0. All right, so we'll do B. Okay, so we have the limit of 4 times tangent of 1 over 4x plus 1 as x approaches infinity. Okay. So whenever you have a trig function, first place you want to look is inside there. Okay. So here we're going to notice that 1, or the limit rather, well, now you don't really need the limit. Let's say that 1 over 4x plus 1, it approaches 0 as x approaches infinity. Okay, so as x gets bigger and bigger and bigger, that gets closer and closer and closer to 0. So that means this will actually become 4 times the tangent of 0. So we know tangent of 0 is 0. That's 4 times 0, which is 0. Okay. Any questions on that one?
You said no, all right, just trying to understand.
Mm-hmm.
1 over 4, x plus 1 is just getting closer and closer to 0.
Yep, it approaches 0. As x approaches 0. Okay. Now for C, like I said, with sine and cosine, they bounce in between -1 and 1. So there is no limit if it's just bouncing between one and the other. Okay, so the limit sine of x as x approaches infinity. Okay, so if you notice that, how sine of x oscillates between -1 and 1. Not really notice, more remember. Probably the wrong word, notice, because they didn't give us a graph. So you want to say remember. As x approaches infinity. Okay. So since it just bounces around and doesn't approach any particular value, the limit doesn't exist. It wouldn't be infinity because it doesn't approach infinity. It just bounces over and over forever and ever. Shows the limit does not exist. Okay, and this is actually the same for the limit of cosine of x.